the dawn of human understanding for potentiality. This isn't a fanciful pipe dream. I mean, this is a specific nature of using molecular geometry to understand that at certain vector points, at this vector point is not the same as this vector point as far as the crystalline lattice structure of the permeability of this quartz silicon dioxide tetrahedra. Okay?
What the fuck did you call me?
I told everybody that.
All right, my peeps, let's break this down. This all started with a video from Ken over at Theoria Apophasis, whatever the hell that is. In it, he makes a bold claim that a quartz crystal can resist a magnet better than another magnet. That's not exactly something you hear every day, so of course it got my attention. Could it be true? That was the only question on my mind, and like anyone who gets sucked into a good experiment does, I ordered a quartz crystal and a 150-pound pull-strength neodymium magnet to see for myself. Ken's video is persuasive. He repeats, "If you don't believe me, try it yourself," so many times it feels less like a suggestion and more like a challenge.
So try this experiment for yourself. You know, I don't care if you believe this experiment. Try it for yourself. You'll see that it works.
But then I had to laugh at myself. Was I the only person to take Ken up on his challenge? Is Ken secretly running a giant social experiment just to see who bites? If so, congratulations, Ken. I took the bait. Do I win a golden ticket now? Now, to be clear, I'm not here to bash Ken. He's entertaining, he's passionate, and he clearly knows how to spark curiosity. I just want to test the claim about quartz and magnets. In his video, he insists you can feel the resistance when you bring the two quartz and the magnet together, but further away for the quartz. This is something he attributes to the convergent-divergent crystalline lattice structure of the flux, or some shit like that. Sounds impressive, doesn't it? So here I am, crystal in one hand, magnet in the other, ready to find out, is there really a hidden force here? Or is this bald monkey freak just yanking my chain? Now the question is, if a bald tattooed monkey freak has a strong magnet like a neodymium one and a quartz crystal in his hand, claiming he can feel a strong magnetic pull or push between them, does he have extra sensory perception, or is he a lying sack of...
That I can actually feel better resistance from a quartz crystal against that 2x2 by 1 inch neodymium block magnet than I can from another magnet.
So join me on a little journey into the wonderful world of quartz, won't you? Quartz is pure silicon and oxygen. It isn't ferromagnetic or even paramagnetic, it's diamagnetic. That means it doesn't get attracted to a magnet, it weakly repels it. And the response is pathetic. Its magnetic susceptibility is around -4 × 10⁻⁻6 in SI units. The force it produces is tiny, on the order of micronewtons for a handheld crystal. It's laughably small. Could he feel this? For a 2-inch quartz crystal, which is about 50 grams, a 1 Tesla field might generate a force of 10⁻⁻5 newtons, less than a mosquito's nudge. Human hands aren't sensitive enough to detect that. Studies on tactile perception peg our threshold at around 0.01 newtons for subtle forces, 1,000 times higher. Even with a 10 Tesla lab magnet, way beyond handheld, the force might hit 10⁻⁴ newtons, still too weak to feel without amplifying equipment. What if the quartz has iron impurities, like in amethyst? Trace iron might add a faint paramagnetic pull, but it's locked in the lattice, not free like in metal. The net effect stays diamagnetic, and any attraction is still in the micronewton range, nothing you'd sense.
I told everybody that.
It's the flux density flow. So, anyway, we're talking about the vectorized nature of silicon dioxide tetrahedra. So, if you got a neodymium like this, and you have a quartz crystal, it doesn't have to be this large, it has to be sufficiently large, at least half this big.
Anyway, I found this fascinating and promptly ordered a similar-sized quartz crystal to see if I could feel these effects.
Let me start by saying, before I go any further, that I have absolutely no connection whatsoever to the New Age movement, to the crystal rubber movement, to the, stick crystals on your forehead, and the whole New Age movement. So I actually have to get that out of the way, since I'm actually going to use a quartz crystal for this demonstration. No connection at all.
Figured out all the secrets of magnetism, which it still blows my mind that it's so simple, and yet explaining is so difficult.
Let's take a look at something neat, and I'd want you to duplicate this yourself. And I'd want you to duplicate this yourself. This is no lie. You can duplicate this yourself. I don't care if you believe me. I don't want to get it too close. It'll jump right there and it'll actually break apart. Then this little quarter-inch neodymium. I mean, let me go out here, even outside of the field. See, I can actually feel nothing out here. How close do I have to get before I feel something? Right about here. Out here, absolutely nothing.
Don't really see it happening. Sorry.
For example, superconductivity doesn't actually exist. Now, if you take a large neodymium block magnet like this, it doesn't have to be this large, it only needs to be large enough, and a decent sized quartz crystal, what you'll have to do is you'll have to turn it and experiment and feeling. You'll actually find, and where is it at right here? Here we go. I have a specific vector where, let me find the furthest reaches. Way out here, actually I'm about 5 inches outside of the field of view, where I can actually feel resistance due to magnetic permeability due to the silicon dioxide lattice nature of this crystal. This is no lie. You can duplicate this yourself. I don't care if you believe me. You're only going to need two things, a magnet and a quartz crystal. It doesn't have to be this large. Here, for example, at this specific vector on the crystal, I actually feel nothing. But at this one, on the tetrahedral silicon dioxide crystal, I get incredible resistance from magnetic permeability, low magnetic permeability, at this distance, which is about 50% further away than the magnet, where I couldn't feel anything. This magnet, this is a powerful neodymium iron boron magnet. I can't feel anything, or even out here. Since these are all actually nickel-plated ceramic neodymium iron borons, it doesn't matter if it's neodymium iron boron. It could be a samarium cobalt, it could be a ferrite, it could be a ferrite. Ferrite's not powerful enough, however.
I purchased an N52 Gauss iron boron block magnet. That's right. This thing will send forks flying if you're not careful. And you know what happened? Nothing. Not a damn thing. F***ing mate. I tried every angle, every face, flipped the crystal upside down sideways. Hell, I spun that thing around for 3 hours straight like I was trying to unlock a cheat code. And guess what, Ken? Still nothing. No resistance, no crystal power, just me, a rock and two magnets staring at each other like a couple of morons.
Ah, shit.
In one direction we have permeability, and through the other direction we have lack of that permeability, or increased permittivity. It doesn't matter how you look at it. Here we have less permeability, and over here we have greater permittivity. Permittivity is not permittivity, and over here we have increased magnetic permeability. Decreased magnetic permeability.
What the hell did you just say?
And this has nothing to do with New Age or nonsense, because as soon as you hold up a crystal and make a YouTube video, and it's exactly what I think. It's like, oh my God, you know, here's some New Age or nonsense.
So yeah, I did Ken's test. And no surprise, I didn't get the same results.
So you're saying, and yes, this is what I'm saying, and you can duplicate this yourself. No, that's not possible.
No, that's not possible.
Yeah, I'm still about 12 inches away on the left side. I'm going to pull it away in 3, 2.
Well, you have to understand what's going on. Quartz crystal structure itself, since it's silicon dioxide, is highly polarized.
Highly polarized.
Magnetic permeability. Superconduct, the yttrium, barium, copper oxide, this hexagonal lattice work that makes up the neodymium iron boron composite. By the way, hexagonal lattice electric capacitance and insanely low magnetic permeability.
What? Bro, what are you talking about, man?
It's the flux density flow.
Here's my 2-inch by 2-inch by 1-inch magnet.
That's not superconductivity at all. So what we actually call superconductivity is absolute absurdity and nonsense.
What the actual did you just say to me right now?
It's simply extremely low magnetic permeability. What we have going on in this, it should be called piezomagnetics. It's going to be a branch of future electronics. We're going to actually have vector-specific read-write data capability. We're going to have vectorized resistors.
In those videos over 10 years ago that all future processors would be bismuth-based. I told everybody that.
So I've kind of deemed this branch of future electronics piezomagnetics. Now,
I told everybody that.
the tetrahedral silicon dioxide crystalline structure.
The tetrahedral silicon dioxide crystalline structure.
I told everybody that.
Perfectly. You can feel the resistance. Like I said, I have no connection to New Age nonsense, no crystal rubbing stuff, no, sticking chakra stones up your butt. The entire universe works off of two principles, force and motion, inertia and acceleration. You have two principles that dictate the entire universe. One is based upon the loss of inertia, i.e. magnetism, the toroidal reciprocating hyperboloid that defines magnetism, and the other principle, which is centripetal convergence, as it will the centrifugal divergence. It's the flux density flow.
What the did you just say?
I told everybody that.
So try this experiment for yourself. I don't care if you believe this experiment. Try it for yourself. You'll see that it works.
I'm going to bring it back in 3, 2, 1.
It's incredibly, incredibly simple. Not simplex, but very simple.
Three-dimensional, very, very simplex.
I posted a thing yesterday. I had some people jump on my back about it by saying, listen, I told you about this over 10 years ago. I posted screenshots of my videos. I said, in those videos over 10 years ago that all future processors would be bismuth-based.
Could he be feeling the magnet's field through his skin? Nope. Human nerves don't pick up magnetic fields directly. That's a myth, unless he's got metal implants vibrating, which isn't the case here. So, is he lying? If he's saying he feels a clear magnetic attraction or repulsion, like the quartz tugging or pushing in his hand, yes, he's either lying or mistaken. Physics says it's impossible with a handheld setup. The force is too small to detect without instruments. Could he be imagining it? Sure. Placebo or suggestion can trick people into feeling stuff, especially if he's hyped up for the video. Maybe he's sensing something else, vibration, tension in his grip, and misattributing it, but magnetism? No way. Sorry, Ken. If you can prove me wrong on this, I welcome it. But as far as this goes, it's busted. Quartz does not have a stronger pull at a greater distance than another magnet. So here's the wrap-up. Ken, do I win? Do I get the prize? A golden ticket to your quartz palace? Because I put in the work, I did the test just like you said. And the only thing I walked away with is a shiny paperweight and 2 magnets strong enough to erase my neighbor's hard drives.
I want no connection with that sort of stuff at all. And I don't want this video to be seen in that light either, because I've got no connection to that, okay? Pseudoscientific quackery, 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 quackery.